Yeah, hi, this is Zach Henson. I am a student in the IO 519 statistics course, and this is my homework assignment, first assignment, and 2.0, and we have homework discussion. The assignment was to search YouTube and find a video that provides a description of the levels of measurement of statistics, submitting the YouTube link in the homework discussion section. So what I've done is I've elected to prepare my own YouTube video with an accurate description and examples of levels of measurement in statistics. So with that said, we'll proceed with the levels of measurement. For doing statistics or analytics, the first step is to understand the variables. Moreover, it's important that one truly knows which measure to take with different available types. This was articulated by Sarub Agrawal and Prasad Pandey, and they have a website called Ride on Data that we'll be using for illustration purposes. The levels of measurement, as they use and describe it, have four characters. They have nominal, ordinal, interval, and ratio. And in those four levels, we'll get onto it with further detail as we move on. But one of the most important and basic steps in learning statistics is understanding the levels of measurement for the variables. Let's take a step back and first look at what is a variable. What is a variable? And a variable can be a quantity that measured and whose value varies through a population. For example, if we consider a population of students, the students nationally, marks, grades, etc., are all variables defined for the entity student, and their corresponding value will differ for each one of those students. Looking at the larger picture, if we want to compute the average salary of the U.S. citizen, we can go out and on record and actually record the salary of each and every person to compute the average, or choose a random sample from the entire population and compute the average salary for that sample, and then use the statistical tests to derive the conclusions for a wider population. The type of statistical tests that can be used to derive a conclusion about the wider population depends upon the level of measurement of the variable under consideration. The level of measurement of the variable is nothing but the mathematical nature of the variable, or how a variable is measured. So, as we can see by the graph, the level of measurement has categorically nominal, ordinal, interval, and ratio. So we then look at the axis, call it the x-axis versus the y-axis. If we look at the x-axis, we have categorically the type of descriptive statistics, the mode, the counts, and the frequencies, the median, the minimum, and the maximum, which essentially drives the range, the mean, the variance, and the standard deviation. So broadly, there are four levels of measurement for the variables. As I mentioned before, nominal level. The nominal level variables are organized into non-numeric categories that cannot be ranked or compared quantitatively. So it puts the variables into some categories. These categories of variable has no ordering and are mutually exclusive, such as each case can only fit into one category. And exhaustive, there could be categories for each possible case, such as shoes can be categorized based on type, sports or casual, color, black or brown. These categories of shoes has no ordering, greater than, less than, or equal to, which are mutually exclusive and exhaustive. Hence, the type variable for entity shoe is measured at nominal level. Ordinal level. In the ordinal level of measurement, the variables are still classified into categories, but these categories are ordered and there is no equivalent distance between the categories, such as class variable for a person that can have values like upper class, lower class, middle class, etc. These values puts a person into a particular category, and there's also a defined relative order between the classes, like upper class is greater than, middle class is greater than, lower class, but there is no equivalent distance or boundaries between these classes. Hence, the class variable is measured at the ordinal level of measurement, which is not as specific. The categories they still must be mutually exclusive and still are exhaustive, but also have a logical order that allows them to be ranked. So upper class, middle class, lower class. Interval level, is the third category. In the interval level of measurement, the variables are still classified into ordered categories, but there is an equivalent distance between these categories. This allows for a direct comparison between the categories, such that the difference between any of the two sequential data points is exactly the same as the difference between any other two sequential data points. The problem with interval level variables is that there is an arbitrary 0 point, such as we can only add and subtract two interval level variables, but we can't multiply or divide them, such as the shoe size. We can say that the difference between size 3 and size 4 shoe is equal to the distance between size 7 and size 8 shoe, but size 6 shoe is not equal to 2 times the size 3 shoe. Also, size 0 shoe does not mean that there is no shoe. It's simply a shoe with a 0 size. It's an arbitrary 0 point. And last but not least, the fourth level of analysis, the ratio level. The ratio level variables have all of the characteristics of nominal, ordinal, and interval variables, but also have a meaningful 0 point. So the 0 point is a real and non-arbitrary, and a value of 0 actually means there is nothing. So we can add, subtract, divide, and multiply the two ratio level variables, such as the weight of a person. It has a real 0 point. 0 weight means that the person has no weight. Also, we can add, subtract, multiply, and divide weights at the real scale for comparisons. Each statistical test is designed to be used with variables of the particular level of measurement. So if we can determine a variable's level of measurement, we can find the statistical test to be used to reach a conclusion by computing the variable under consideration for a random sample of a population. Sometimes a nominal level variable, such as race, can be misinterpreted as an interval level, such as 1 equals white, 2 equals black. Simply adding numbers to the nominal level variable doesn't make them the ordinal or the interval level variables. That concludes my analysis of the 4 level variables